One of the first lessons this year that may not be a review for you is absolute value equations. And the first thing we're going to look at is what the definition of absolute value is. The absolute value of a number is its distance from zero on a number line. And we use the symbol, a straight line with the variable in the middle and another straight line to represent the absolute value of a number, in this case x. The first example we're going to look at is evaluating an expression with absolute value. So when you're asked to just evaluate, remember that just means to solve, and we have the absolute value of 4x plus 3 minus 7 halves. If x equals negative 2, we want to know what is the value of that expression. So the first thing we're going to do is plug in negative 2 for x, and then we're going to start solving. And remember, remember to use our order of operations. We start with the grouping symbols, or the parentheses. In this case, it's the absolute value brackets. So we're going to do 4 times negative 2, which is negative 8. And then we rewrite everything else. Plus 3 minus 7 halves. Again, we're not finished with the absolute value bars, so we're going to continue along by doing negative 8 plus 3, giving us negative 5 minus 7 halves. From there, we're going to continue working with the absolute value bars, knowing that negative 5 is 5 spots away from 0. So when we take the absolute value of negative 5, we come out with 5, and again, minus 7 halves. Since we're working with fractions, we can change that 5 to 10 over 2, and when we do our subtraction to finish the problem, we end up with 3 halves, which is our final answer. Now, in my class, you can use decimals when they are either repeating decimals or terminating decimals. So, for instance, 3 halves, we could write that as 1.5, and that would be okay. And you could have gone back up into the problem where we had 5 minus 7 halves, and you could have changed that 7 halves to 3.5 also, and that's okay. But I also am a big fan of using improper fractions because those are more exact answers. There's no rounding. So 3 halves or 1.5 is acceptable. Moving on to example 2, where we're actually going to solve an absolute value equation. Noticing that example 1 was an expression, there was no equal sign. Now we're working with equations. So looking at the first example, we have 9 equals the absolute value of x plus 12. The first thing we're going to do is we are going to split that up into 2 separate equations. Notice that the side with the absolute value bars, we just rewrite everything that's inside of them, and it's the opposite side that we have to take into account that the absolute value could be positive, so we have positive 9, or it could be negative, so we have negative 9. So once you've split up the equations, then you're just going to simply solve them. So starting on the left, we're going to subtract 12 onto both sides, and we end up with negative 3 equals x. And on the right, when we subtract 12 on both sides, we end up with negative 21 equals x. So those are our 2 values for x. You have to be careful, and you have to make sure you check your work, because sometimes one of the values, or maybe both of them, will not work. So when you check your work, you're plugging it back into the original. So we have 9 equals the absolute value of negative 3 plus 12. Negative 3 plus 12 is 9, so the absolute value of 9 is 9, so that one works. And also when we plug in negative 21, it's 9 equals the absolute value of negative 21 plus 12. Negative 21 plus 12 is negative 9, but when we take the absolute value, it's positive 9. So both of these answers do work in this situation. Moving along to example B. Notice that example B is a little bit different than example A because there's a negative 2 in front of the absolute value. And in order to start this problem, we need to get rid of that negative 2 so that we just have the absolute value equal to an expression on the other side. So in order to get rid of the negative 2, we're going to divide that on both sides. So now we're at our starting form of the absolute value of 3a equals negative 3. Doing that before you start is extremely important because if you do not, there are many instances where you're going to end up with incorrect answers. So make sure you, in order to start the problem, you have just the absolute value equal to an expression on the other side. Then from here, we're going to do the same thing. Typically, we would split it up where we'd have the absolute, we would just have 3a equals negative 3, and then 3a equals positive 3. However, is there any way that the absolute value is going to come out negative? The answer to that is no. The absolute value can never equal a negative number, therefore there is no solution. So you could either write no solution, or you could do that little 0 with the slash through it. That is our notation for no solution. It's an empty set notation. Giving you a second here so that you can get that information copied down. All right, and we're going to move on to our last example, example C. This one looks a little bit more complex, but really, once you get it in starting form, it's the same as example A was. So in order to get it in starting form, if we look at that left-hand side, because that contains the absolute value, we need to get rid of that 2, and we also need to get rid of that negative x. We're going to go ahead and move that negative x to the other side by adding it, and then you need to divide by the 2 on both sides. So take a second and do that, and let's see what you end up with as your starting form, your equation that we're going to start with for the absolute value. All right, so hopefully you came up with something that looks like this. The absolute value of x plus 1 equals 2x minus 2. Remember, on that right-hand side, you have to divide each term by the 2, not just one of them. So that's how we end up with the 2x minus 2. All right, so now that we have the starting form, we're going to leave everything that's in the absolute value exactly as it is. We're going to split this up into 2 equations. And the first equation is going to be x plus 1 equals 2x minus 2. And then we have x plus 1 equals negative the quantity of 2x minus 2. Putting that negative out front of the parentheses, again, is extremely important because you need to distribute it to both the 2x and the negative 2, which is going to, in turn that negative 2 into a positive. So now I want you to take a couple of minutes here and solve each of these equations separately and get 2 x values. All right, so the first equation on the left, you should have ended up with x equals 3, and then on the right, you should have ended up with x equals 1/3. And remember, we always need to check that our values work by plugging them back into the original equation. So again, I'm going to give you another minute, minute and a half to go ahead and plug both of those values back into the beginning equation and see if it works. All right, so when you plugged in the x equals 3, you should have ended up with a true equation. However, when you plug in 1/3, you're going to end up with an equation that is not true. So what does that mean? That means that 1/3 is actually not a solution. So the only solution is 3. And that's just written in set notation with those silly brackets around it. Call them squiggly brackets. You could just put x equals 3. That's fine. So that is the last example for these notes. I will have this video put on the website as well, so as you're working through the practice today in class or tonight, you can use the video to reference if you need to. Please remember, if you have questions, go onto the Edmodo site and ask it so that either a classmate can answer it or I can answer it. I do that pretty frequently. And other than that, you have the back of the worksheet that you can work on for classwork and homework.